We've all heard the warnings about climate change. The ice caps are melting, the seas are rising, and the future looks hotter than a supernova. Imagine using technology to literally hack the planet, scrubbing carbon dioxide from the air, or reflecting sunlight back into space. It sounds like science fiction, like something straight out of a Star Trek episode, but the science is real. So, buckle up, fellow Earthlings, because in this video we're diving headfirst into the wild world of geoengineering. We'll explore the most radical ideas, from giant space mirrors to artificial volcanoes, and grapple with the biggest question of all. Can we engineer our way out of a climate catastrophe, or are we just messing with forces we don't understand? All right, let's start with the basics. What exactly is geoengineering? In a nutshell, it's like giving the Earth a technological tune-up, using science to deliberately manipulate the planet's climate system. I know, it sounds audacious, even a little bit scary, right? But here's the thing, the climate crisis is real and it's getting worse. We humans, in our infinite wisdom, have been pumping greenhouse gases into the atmosphere for centuries, like we're trying to bake the planet from the inside out. And while cutting emissions is crucial, think of it as putting the Earth on a carbon diet. It might not be enough to avert the worst effects of climate change. Enter geoengineering. It's a suite of technologies, some still on the drawing board, that aim to fix what we've broken. There are two main approaches: removing carbon dioxide from the atmosphere, which is like cleaning up the mess we've made, or reflecting sunlight away from Earth, which is more like putting up a giant sunshade. Geoengineering is a controversial topic, and for good reason. We're talking about tinkering with complex systems we don't fully understand, and the potential for unintended consequences is huge. But here's the other side of the cosmic coin. The potential benefits are also enormous. Imagine being able to halt the melting of glaciers, prevent devastating sea level rise, or even cool down the planet with the flip of a switch. Over the next few chapters, we'll delve deeper into the different geoengineering approaches, exploring their potential benefits and risks. We'll separate the science fact from the science fiction, examine the ethical dilemmas, and ask ourselves the toughest question of all. Is geoengineering a viable solution to the climate crisis, or a dangerous gamble with our planet's future? Let's start with the most intuitive approach to geoengineering, cleaning up our mess. Carbon dioxide removal, or CDR, aims to do exactly what its name suggests: suck that excess CO2 right out of the atmosphere. It's like giving the planet a giant air purifier, or maybe a really intense detox smoothie. One CDR method getting a lot of buzz is called direct air capture. Picture this: massive machines, like something out of a futuristic cityscape, that suck in air and chemically extract the CO2. It's like a giant vacuum cleaner for the sky. The captured carbon can then be stored underground, locking it away safely for centuries. Sounds promising, right? But hold on, there's a catch. Direct air capture is still in its early stages, and it's currently very expensive and energy intensive. We need to develop more efficient and affordable technologies before we can even think about scaling it up to a planetary level. Another CDR approach involves giving Mother Nature a helping hand. Ocean fertilization involves sprinkling iron filings into the ocean, which acts like fertilizer for phytoplankton, those tiny plant-like organisms that form the base of the marine food web. The idea is to stimulate phytoplankton growth, which absorbs CO2 from the atmosphere through photosynthesis. But again, there are concerns. Dumping iron into the ocean could have unintended consequences for marine ecosystems. So, CDR has the potential to be a powerful tool in the fight against climate change, but it's not a silver bullet. Okay, ready for something a little more radical? If removing carbon dioxide is like, then solar radiation management, or SRM, is like dimming the lights. It's a way to quickly cool down the planet by reflecting a small percentage of sunlight back into space. We're not talking about blocking out the sun entirely. Thermostat a bit. Chapter 4, Stratospheric Aerosol Injection, Mimicking Volcanic Eruptions. So how do you go about dimming the sun, you ask? Well, one idea is to take inspiration from nature volcanoes, to be precise. When a volcano erupts, it spews tons of sulfur dioxide into the stratosphere, which forms tiny particles that reflect sunlight back into space, temporarily cooling the planet. Stratospheric aerosol injection aims to replicate this effect artificially. We're talking about using planes or even giant balloons to inject sulfur dioxide or other aerosols into the stratosphere, creating a sort of global sunscreen. It sounds a little crazy, I know, but the science checks out. And here's the kicker: stratospheric aerosol injection could potentially cool the planet within a matter of months, but hold your cosmic horses, because there's a catch. Messing with the stratosphere is a risky business. We're talking about potentially disrupting weather patterns, altering precipitation, and even depleting the ozone layer. And the effects wouldn't be evenly distributed. Some regions might benefit, while others could experience droughts, floods, or other extreme weather events. And what happens if we stop injecting aerosols? The planet could warm up rapidly, leading to even more abrupt and dangerous climate change. So while stratospheric aerosol injection might sound like a quick fix, it's more like a band-aid on a gaping wound. It doesn't address the root cause of climate change, our reliance on fossil fuels, and it comes with a whole host of potential side effects that we're only beginning to understand. All right, let's talk about something truly out of this world. Literally. Space mirrors involve launching giant reflective mirrors into space to block a small percentage of sunlight before it reaches Earth. It's like giving the planet a pair of sunglasses, or maybe installing a giant patio umbrella in space. I know it sounds like something out of a science fiction movie, but the concept has actually been studied by scientists, and it's not as far-fetched as you might think. In theory, space mirrors could reflect enough sunlight to offset the warming effects of greenhouse gases. But here's the catch, and it's a big one. Deploying and maintaining a fleet of space mirrors would be astronomically expensive and technologically challenging. Blocking sunlight could have unforeseen impacts on plant life, weather patterns, and even the Earth's energy balance. So, we've covered a lot of ground, from sucking carbon dioxide out of the air to launching giant mirrors into space. It's clear that geoengineering offers a range of potential solutions to the climate crisis, but it also comes with significant risks and uncertainties. It's like we're standing at a fork in the road. Down one path lies the familiar, albeit perilous, route of cutting emissions and adapting to a changing climate. Down the other path lies the uncharted territory of geoengineering, a world of both promise and peril. Geoengineering is not a silver bullet, and it should never be seen as a substitute for reducing our reliance on fossil fuels. It's a last resort, a planetary insurance policy that we should only consider if all else fails. But as the climate crisis worsens, we may not have the luxury of ruling out any options. We need to invest in research and development, engage in open and honest public dialogue, and proceed with extreme caution. But even if we can overcome the technological challenges and scientific uncertainties, there's another layer of complexity to consider: the ethical implications of geoengineering. Who gets to decide whether or not to deploy these technologies? And who's responsible if something goes wrong? These are not hypothetical questions. We're talking about decisions that could affect the lives of billions of people, not to mention countless other species for generations to come. It's a responsibility that should not be taken lightly. One of the biggest ethical concerns is the issue of consent. If one country decides to deploy geoengineering technologies, it could have unintended consequences for other countries that had no say in the matter. And then there's the question of moral hazard. If we know that we have geoengineering as a backup plan, will it make us less likely to address the root causes of climate change? Will it give us a false sense of security, leading us to delay action on reducing emissions and transitioning to a more sustainable way of life? We need to have a global conversation about geoengineering, involving scientists, policymakers, ethicists, and the public. So, there you have it, geoengineering, a set of technologies that could save us from climate catastrophe or potentially make things even worse. We've explored the science, the risks, and the ethical dilemmas. We've seen how geoengineering could buy us time to transition to a more sustainable future, but also how it could have unintended consequences that ripple across the planet for generations to come. The question is, what do you think? Is geoengineering a risk worth taking? Is it the ultimate act of hubris, or a necessary tool in the fight for our planet's future? Let us know in the comments below.